Today we're going to do quadratic equations with a. All right, what we've done before is just x squared plus bx plus c. Now they're adding a, so it's slightly different than what we've done before. You still use the same methods to solve for it, but there's one extra step. What we do is we have ax squared plus bx plus c. We're going to split b into m and p, just like before, because m and p add to give you b, and m and p would multiply to give you c, but not just c. Right? When there wasn't an a, it was just m times p gave you c. Here, m times p gives you ac. It's a combination of the first number and the last number, which it'll make more sense when we throw in. So write this down. So here you're given 7x squared plus 29x plus 4. What we've been used to is this not being there and just finding what x squared plus 29x plus 4 factors. So make sure you know the difference. What I'm going to do is I need to figure out what adds to give me 29. And I need to find what multiplies to give me what? What would be the number I'm looking for? Okay, that's what we're used to. We're used to looking for what multiplies to give me 4. But since there's an a here, I need to figure out what multiplies to give me 28. 4 times 7. I multiply these. Remember, m times p added to give me, or multiply to give me ac, which is 7 times 4. So I go through my factors of 28, which 1, 28, 2, 14. I'm looking, which ones add to give me 29? 1, okay, 1 and 28. So, and we don't just, where we went, what we did was we would just go x plus a number and then x minus a number. We don't do that anymore. Right? It's slightly different. Instead, what we do is we rewrite the quadratic equation 7x squared, and instead of writing 29x, we write 28x plus x, or 1x. We write the factors we find. We found these factors added to give me 29, so I write those two. And then I add, and then I write plus 4. So I just rewrite the equation, but I've split 29x into 28x and x. It does, like, it kind of matters though on the order you write them, because here what we're going to do now is we're going to solve by grouping. We've done this before by grouping these two and figuring out what can we factor out of each. So what can I take out of 7x squared and 28x? You could take x out. Anything else? 7. What's left of 7x squared if I took 7x out? X. What's left of 28x if I took 7x out? 4. Here, what could I take out of x and 4? There's only one thing I could take out. What would it be? 1. Which would leave you with x and 4. Right, remember, you want these to be the same thing. We've done this before. So now I combine the 7x and 1, and I combine your x plus 4s. There's the answer. Here you've got 3x squared plus 15x plus 18. Now we could go and do just like we did, but there's a shortcut. Does anyone recognize something about this? Anything that you see? Yes, Kyle.
3 and 5.
3 and
15.
3 and 15 and 18. 3 is a common factor of all three of those, isn't it? So I could go ahead and factor 3 out. I'm left with x squared plus 5x plus 6. Now I just do like what we've been doing. What adds to give me 5 and multiplies to give me 6?
3 times 2.
Yep. That's exactly what it is. So 3's on the outside, okay, and I just do x plus 3, and I just do x plus 2. Just like we've been doing. All right? And then that's it. That would be your answer. So if you can factor, if you see a common factor of all three of those, you can factor it out, make it easier. If there's not, then you do like the problem before. So let's do one of those. Write this down. So here, I look at this, I don't see a common factor. I don't get lucky like I did on the one before where I could take 3 out of each. So here, I just have to go through and I have to figure out what adds to give me 13 and multiplies to give me what, Gage?
Multiplies 6.
Nope.
Or 5. Or 15.
Savannah?
30.
I'm looking for what multiplies to give me 30. Because there's an A here, I have to multiply A and C. From my rule, I have to multiply and C. If there's no A, then I just look at C. But if there's an A, I have to multiply those. Make sure you're aware of that. So now I go through my factors of 30. 1 and 30. 2 and 15. Right, which those would subtract to give me 13. But is there a minus sign anywhere? No. Right? C is positive, meaning either they're both positive or they're both negative. And B is positive. That means they're both positive. So I can't use 2 and 15. 3 and 10.
Yeah.
There it is, right there. So I just rewrite this and I split 13x up. So 5x squared. And I'm going to go 10 first because 10 goes with the 5. And then I'm going to go 3 next because 3 goes with the 6. I want common factors together. So then I solve by grouping. What can I take out of 5x squared and 10x? 5x. I'm left with x plus 2. So I got to make 3x plus 2 into x plus 2. What could I take out of 3x plus 6, Richard?
2. Wait, my bad. You can take out the 3 out.
I could take the 3 out.
My bad.
What would be left?
That's alright.
What would be left?
6.
If I took
Oh, your x.
x would be, and then what else would be left?
Oh, your 3.
6 divided by 3 would be
Oh, 2.
2. I've got to make x plus 2. I got to make it x plus 2. So now I combine the 5x and the 3. And then I combine the x plus 2. There's my answer. 6x squared plus 22x minus 8. First thing I do is I notice that 2 is a common factor of all of those. I'm going to factor it out. That gives me 3x squared plus 11x minus 4. Now you can do it without doing this, but it's a whole lot easier if you factor something out. So now I look, what would add to give me 11? What would multiply to give me negative 12? Well, I mean, that it'd have to be 12 and negative 1, right? So 3x squared, which I'd want to go with 12 here, so I'm going to say plus 12x minus 4. And all of that is times by 2. But you really don't have to remember, I mean, you just have to keep that in there. Then I group those. I could take 3x out of 3x squared and 12x. So that leaves me with x plus 4. I've got to make the other one x plus 4. So I would factor negative 1 out. That leaves me with x plus 4. So I combine 3x and negative 1. Combine the x plus 4. And remember, the whole thing was times by 2. Here, right, this is where b is negative. All right, b is going to be negative. So I look at what would add to give me negative 1 and multiply to give me negative 2, because I take negative 1 times 2. Well, what adds to give me negative 1 multiplies to give me negative 2. 2 and 1, right? Multiply to give me negative 2. Which one would be negative and which one would be positive? The 2, would it be positive or would 2 be negative? 2 would be negative because the bigger number has to be negative. If b is negative, then the bigger number has to be negative. So I do 2n squared minus 2n plus n minus 1. What could I take out of 2n squared and 2n? Anybody? I could take out n. What else?
1, 2.
2's. I only look for 1 if they don't have like a common factor. Here they have common factors, 2 and an n. So you have n minus 1. What could I take out of n and negative 1? 1. So I'm left with n minus 1. I don't want it to change since it's already what I want it to. So 2n plus 1 and n minus 1 is your answer. I looked to see, I do have a common factor there. I can take 5 out of all of that. That gives me 2y squared minus 7y plus 6. Much easier to work with. So I'm just going to, I forget about the 5 until the end. So I need to figure out what would add to give me negative 7 multiply to give me 12. Kyle, did you get that right? Okay, don't forget to multiply these two. Well, so I go through my factors of 12. You got 1 and 12, 3 and 4, 6 and 2. Which one of those would add to give me negative 7? Okay, since they both have knowing that since C is positive and B is negative, I know they're both negative. So we're both going to add to give me a negative 7. So they're both negative. So 2y squared minus, I'm going to go with the 4 because the 4 goes with the 2. So 4y. And I'm going to go with the 3 at the end because the 3 goes with the 6. So 3y and then plus 6. I group those. I can take 2y out of 2y squared and negative 4. That gives me y minus 2. So I've got to make the next one y minus 2. So I can take negative 3 out. That gives me y minus 2. Combine those. 2y minus 3 and y minus 2. And don't forget that 5 you factored out at the beginning. And there's your answer. Right? A polynomial that cannot be written as a product of two polynomials is what we call a prime polynomial. So if you see something that doesn't factor whatsoever, we're going to call that a prime. Now you write prime. Now everybody understand? Hey, if it doesn't factor, because sometimes you just can't factor. There is ways of solving them, and you're going to learn about that soon. But if you can't solve, like if you can't factor it, then we call it prime. Such as a problem like this. Write this down. Now you're not going to know whether it's prime or not. You're going to be told to factor it if possible. If it cannot be factored, then write prime. So let's try to factor it. Let's see if it's prime or if it's not, then we can factor it. So I'm looking at what would add to give me negative 3 and multiply to give me 20. Well, let's go through my factors of 20. 1 and 20, 2 and 10, 4 and 5. Right? Are any of them give me negative 3 as a sum? Do any of those add to give me negative 3?
No.
All right. Does 1 and 20 add to give me negative 3? No. Does 4 and 5 add to give me negative 3? No. So can I factor this? No. So that's why this is prime. And that's all you write. All right, prime, because I cannot factor it using integers. Any questions?